Welcome to my class Physics Untold. Here I am representing a question from Pathfinder for Olympiad and JEE Advanced, and this is our problem number 20 from Build Your Understanding. So let us start this question. The question is a ball of mass m is suspended from a bar of mass capital M. Suspended from a bar of mass capital M with a light inextensible cord. The bar can slide on a frictionless slope of inclination theta. Initially, the bar is held motionless so that the ball also stays motionless as shown in the figure. Find acceleration of the bar and the ball relative to the ground immediately after the bar is released. Acceleration due to gravity is g. So first of all, let us describe this question. In this question, it is given that there is an inclined plane whose angle of inclination is equal to theta, and on this plane there is a mass capital M which is stressed on the inclined plane, and there is a string which is joining the mass capital M, and this mass is equal to small m. This mass is equal to small m, which is joining the capital M and small m via inextensible cord. So as the motion is holding, as there is the inclined plane, so the motion will always act along the plane. So let this acceleration along the inclined plane is equal to a1. Let this acceleration is a1. But if we and as the mass m1, mass small m is going or moving vertically downward, so let its acceleration, the acceleration of small m is acting vertically downward. Let this acceleration is equal to a2. Now we can express or we can find out a relation between a1 and a2. So first of thing, if we divide the a1 and a2 into components, so if we divide a1 into components, then component of a1 will be like this. If this angle of inclination is equal to theta, therefore this angle must be equal to theta, or acceleration component along the horizontal is equal to a1 cos theta, and acceleration component in the vertical direction, must be equal to a1 sin theta. And in the reverse manner, we can also divide the acceleration a2 into components. If we divide acceleration a2 into components, then its acceleration should be, let a2, if we let us divide or resolve this acceleration into components. So there will be two components of a2. One is equal to, if this angle equal to theta, then this angle must be equal to theta, or this component or component perpendicular to the inclined plane should be equal to a2 cos theta, and acceleration component of a2 along the inclined plane should be equal to a1, a2, this component equal to a2 sin theta. But this is not possible. Second case is not possible, because as the total motion, because the net acceleration is holding along the inclined plane, so there must not be present any component of acceleration along the perpendicular direction of the inclined plane. So these components are not true options. Therefore our true options is, therefore we can decide the acceleration, the relation between a1 and a2 should be equal to A2. A2 equal to A2 equal to A1. A2 equal to A1 sine theta. This is our correct choice for finding the relation between acceleration A1 and A2. Now let us draw the FBD for this diagram. So for mass small m, there is a weight of mass m which is equal to mg, which is acting vertically downward, and there is a tension force which will acting vertically upward direction. So this is our tension force T. Now the component, and there is a weight mg which is acting vertically. There is a weight mg which is acting vertically downward direction. So this is our component of weight mg. This is our weight mg, and there is a normal reaction. There is a normal reaction of the mass capital M. So this normal reaction must be perpendicular in the perpendicular direction of the inclined plane. So this normal reaction, this normal reaction is equal to N. Now we can write the equation motion for this situation. So for writing the equation of motion, we can write the equation of motion as mg. For capital M, we can write the equation of motion as capital mg capital M g, which is acting vertically downward. And now if we resolve this n into components, then we can write this angle is equal to theta. Therefore this component, the component perpendicular vertical component of n should be equal to n cos theta, and the horizontal component of n should be equal to n sine theta. This component is equal to n sine theta. So for the balancing of mass m2, then we can write this equation as mg plus T, because also there is a tension of the string or thread, which is T, which is also acting vertically downward, minus the vertical component of the normal reaction, which is equal to n cos theta, which must be equal to mass of the capital M, which is capital M, multiplied with its acceleration. So acceleration component is there in the vertical direction. As we are seeing, this acceleration is equal to A, or this component is equal to A2. We can write this equation. Again, we can balance we can write the normal reaction equation as, from normal reaction we can find the normal reaction here is acting N, and if we further divide this mg and T into components, then we can also find there is a component in this direction which is equal to, as this total equal to mg plus T, or we can write this component equal to mg plus T into cos theta, mg plus T into cos theta. So for balancing, as there is no acceleration perpendicular to the direction to the in the perpendicular direction of the inclined plane, as this is not valid, therefore we can write this acceleration is equal to perpendicular acceleration equal to 0. Then the normal reaction, then we can write this equation N minus mg, n minus mg plus t into cos theta, which is equal to 0. Or from this case we can write the value of normal reaction n, which must be equal to capital mg, which must be equal to capital mg plus t, capital mg plus t into cos theta. Now we can substitute the value of n, value of this normal reaction, into the first equation. Then if we substitute this value of normal reaction, then we can get the equation or solve this equation as mg, capital mg plus t, capital mg plus t minus value of n equal to capital mg plus t into, as there is also cos theta, and cos theta multiplied with cos theta must be equal to cos square theta, which is equal to m, which is equal to ma2. Or if we simplify this equation, then we can write, there is a mg, we can take as mg equal to as common, then after taking mg as common, there is remaining is 1 minus cos square theta, plus there is also t, which we can take as common, into 1 minus cos square theta into 1 minus cos square theta plus mg cos theta plus mg plus, which is equal to ma2. Or we can rewrite this equation as, or we can take total mg as common, or this 1 minus cos square theta is now become equal to sin theta, sin square theta, or we can write this equation equal as mg plus t into sin square theta equal to ma2, equal to ma2. Let this is our equation number 1. And if we further write the equation of motion for small m, then from the small m we can write the its equation as its acceleration is vertically downward. Therefore its weight is equal to mg. We can write its equation as mg minus its tension T, which must be equal to ma2. Let this is our equation number 2. Now we can eliminate the T from this 2 equation, or we can solve this equation. Therefore we can, after solving this equation, we can take the value of, from the equation number 2 we can write the equation value of T, which is equal to mg, which is equal to mg minus ma2, mg minus ma2, and we can substitute the value of T in equation number 1. So after substitution we can rewrite this equation as mg sin square theta as mg plus T, which is equal to mg minus ma2, mg minus ma2 into sin square theta into sin square theta. This is mg plus T into sin square theta. But also one thing is missing here, because in this equation there is mg plus T plus n cos theta. So this is now becoming mg plus T minus mg, or okay, Or from this equation we can write mg plus small mg minus ma2 sine square theta, which must be equal to ma2, which must be equal to ma2. Or we can write the equation for ma2 or from this equation we can rearrange. If we rearrange this equation, then we can write here as small capital M plus small m sine square theta plus small m sine square theta into a2, which must be equal to capital M plus small m into g sine square theta. Or from this equation we can find out the value of a2, which must be equal to capital M plus small m into g sine square theta into g sine square theta whole divided by capital M plus small m sine square theta, small m sine square theta. So this is the value of a2. But what is a2? But a2 is nothing but the acceleration of, this is the acceleration for the small mass, acceleration for the small mass small m. Now also we already find out the relation between a1 and a2, and from the relation of a1 and a2 we can write the equation for a1 must be equal to a2 divided by sine theta, a2 divided by sine theta. And we already find out the value of a2. Therefore we can substitute the value of a2 here. If we substitute the value of a2, then we can write here this equation as capital M plus small m into g sine square theta divided by capital M plus small m sine square theta into sine theta. Or from this equation, this one of the sine theta will cancel out, and we can write the value of a1 or acceleration of the block capital M, which is equal to capital M plus, which is equal to capital M plus small m into g sine theta into g sine theta divided by capital M plus small m sine square theta. So this is our required acceleration a1 and a2. And now this a2 acceleration is the acceleration of the ball of the mass m. Now this a1 equal to, this is acceleration of ball of mass small m, and a2, this is a1, which is the acceleration of mass capital M. This is acceleration of mass, this is the acceleration of mass capital M, of mass capital M. Here one thing is to be mentioned here. The one important concept which is used here, the string will remain taut, because for it to be slack, acceleration of capital M must be greater than g downwards, which is not possible. As the cord is taut, acceleration of both along the thread must be equal. This is one of the important concept which is used for solving this problem. Thanks for watching this video. Like, subscribe and share for more videos like this. Thank you.